So, good afternoon, everyone. So, this is our first interactive session. So, whether this screen is visible to everyone. Hello, Pritam. Hello, Pritam. Can you please turn off your mic? Thank you. So, first, let me introduce myself. I am Niloy, and I am your TA for this interactive session. So, these courses already you have attended some lecture. I hope that you have attended this lecture, and based on this lecture, some numerical problem and some doubts we are going to clear today. And I hope that you have got some assignments. So based on this assignment, we have some similar types of problem that I am going to solve for you today. So whatever may be the problem you are facing or you have any doubts, it's better to raise this doubt in this chat box. So feel free to ask in the chat box, then it will be better for me to find out this who is asking this question, right? So before starting this, so this is some details about this course. So this course is not only for engineering, this is also for other branches and other people who are interested in doing this interdisciplinary course. So basically the students who are currently in their BTech courses in civil engineering, mechanical engineering and chemical engineering, this course is quite vital for their academics. So in these courses we'll get to know how we'll have to solve some real life problem, and this approaches through this control volume concept and the streamline pattern and all these things. I hope that you will still haven't understand this concept. So this concept we will get to know in the upcoming lecture. So see this volume control volume concept and the streamline pattern. So these things you will study in the upcoming classes, and how we will have to solve this real life problem, that thing we will learn through this problem solving session. So based on some course detail, so these course details, if you see, this started from this 21st July and it will end on 10th October, and this tentative exam date is around on November 1st. So if anyone is interested to give exam, please enroll for this exam by 12th by 15th August 2025. So So anyone is interested, so please do the needful, right? So I think that it will be better for you if you will go through these courses and have an exam. So that you will get to know how you have understand this course, or how you will know this course in details. So in this, in the first week, this is the first week, and this in the interaction session, we will discuss about some sample problem on this basic concept of fluid, properties of fluid, fluid flow analysis, um, and and before starting, after each question I will give you some minutes time, say 1 minute or 2 minutes, so that you will solve this question by yourself if possible, as I will also solve this question after 2 minutes, and let us see how many students can be able to solve this question, as you have already gone through these regular classes. So if you have any question, any problem or any doubts, feel free to ask in the chat box. So this is our first question. So in the first question, it is asked that a fluid occupies 20 meter cube. That is means the volume of the fluid. So now you are asked to find out this specific volume if the fluid mass is 8 kg. So what is given basically in this question? In the question, just just a minute. Huh. So the volume is given and the mass is given. So first I am giving you 1.5 minutes to solve this one, and please if anyone solve this question, please write down in the chat box, so I'll get to know that how many fellows are going to answer this question. Okay, Disha has answered it as 1.5. So student, please try. Whatever you have understood, just try. And Pritam has answered is as 2.5. And Gary has also answered it is 2.5. Mm, yes, many of the students are answering. That's good. Okay. So let us check this answer. So see, before answering this question, you need to know about the specific volume. So what basically is specific volume? So specific volume basically means the volume occupied by unit mass of a fluid. So see, let us assume this is a container. So in this container there is some liquid. So the liquid has some volume. Say let V be the volume and M be the mass. So specific volumes indicate, say, if you are taking some water from this vessel, say this portion which I am highlighting. So in this portion, if I have to specify only for this portion, so I have to specify it in terms of this specific volume. So the specific volume basically indicate that the volume of the fluid, which I can represent as V, and mass of the fluid. So these will eventually give details about this small portion that has been highlighted. This gives the volume. So what is the volume here? Here the volume is 20 meter cube and the mass is 8 kg. So another thing, so here V is 20 and mass is 8 kg. So in the exam, it may be given that the volume is 200 centimeter cube. So if the unit is given in any other format, so you have to convert it in terms of meter. So remember this thing always. And and also in some cases the weight, in some cases this mass can be given in terms of gram. So you have to convert it in terms of kg. So what I will get? So I will get this answer as 2.5 meter cube per kg, right? So that is the answer, and many of the student has given the right answer, and some have done mistakes, so it's okay. You will just practice and you will get the right answer. Okay, so this is the answer. So and another thing, that this slide I will share with you after this classes, and you will get all this answer. So similar question you will find in your assignment. So using this same concept, you will be able to solve this in the assignment. So I hope that this will definitely help you. So the answer is option C. So coming to the next question. So this is the next question. So in this question, the question is, an ideal fluid is, the first option is either it is non-viscous and incompressible, B is viscous and incompressible, C is viscous and compressible, and D is non-viscous and compressible. So that means you need to know about the what is an ideal fluid is, and if you have gone through this class, I hope that you will be able to answer this question. So I am giving you 1 minute time to answer in the chat box. Mm. So Ravi and Vidisha has answered option A, that is non-viscous and incompressible, and Shudha has answered incompressible and viscous. Okay. Mm. Okay, many of you have answered it. That's great. Yes, it's correct. Answer name. So see what is basically an ideal fluid is. So it's basically a theory concept. In real life, there is no such ideal fluid. So this ideal fluid is basically a theoretical concept which is used to simplify your fluid mechanics problem. So what, as I have said that it's a theoretical concept, so we assume the viscosity as 0. In real life, no such fluid is there where the viscosity is 0. So viscosity means 0 means that there is no internal resistance to flow. That means if a fluid is flowing over if a fluid is flowing over a surface, then there is no such resistance in its path. So in real life it is not possible, but for our problem solving and in any mm, real life, in any problem like in engineering problem, or if you are if someone of you are in final year, you are doing some project, in that we are always assuming this as in majority of the case we are assume the ideal fluid. And also another important point is it is incompressible. So what basically is incompressible? So incompressible means throughout this domain, so this fluid, say this is point 1 and this is point 2. So 2 points, these 2 points, if the density whatever be the density at point 1 and the density at point 2, if it's remain constant, then we know that it's an incompressible fluid. Even another point, say another point is here, so this is 3. So what will happen then, density at 3 should be also same. So for an ideal fluid we have got it should be non-viscous and incompressible. Okay, but for real fluid have some viscosity and also it has some it is compressible. Say in ideal fluid, if you are applying some force on this fluid, say this is F force, even after applying this force the density of the fluid will not change. So that's why it's a called, it is known as ideal fluid. Also, I think in class 11 or 12 you have studied about this Bernoulli's equation, Eulerian equation. So you can only apply those equations if the fluid is incompressible and have zero viscosity. That means it should be ideal fluid. So that means this assumption is also used in the application for Bernoulli's equation. So the correct option answer is option A, non-viscous and incompressible. So coming to this third question, so where it is given the kinematic viscosity is expressed in, so these are the four options. So please try by yourself. I am giving you 2 minutes. Good, many of you are answering. Okay, many of you have answered it correctly. So, what basically is kinetic viscosity? So this kinetic viscosity means it is the ratio of dynamic viscosity to density. Say if I represent kinematic viscosity as nu and dynamic viscosity as mu, and it is I know that we know that it is the ratio of dynamic viscosity by density. Density can be represented as rho, right? So now this one is dynamic viscosity. So say you do not know about this SI unit, or like how will you find out? For this dynamic viscosity, you know this its unit is Pascal per second. So what basically is Pascal? Pascal means Newton meter square. Okay, and for density, what is its unit? Density is mass by volume. So mass means it should be kg. Volume can be represented in meter cube, right? So I can write in place of mu, it should be nu by meter square into second. What this is kg by meter cube, right? Now you just solve. So also we know Newton. Newton is the unit of force. Force means mass by acceleration. So you can accordingly find out what basically Newton represent. Sorry, force equal mass into acceleration, and I just said it wrong. To kg into, just a minute, Newton is meter per second. So you just put it here. In terms of Newton, it is kg meter per second square, and you will get it as meter square per second. So the correct answer is option D. So basically, what kinematic viscosity indicates? It indicates how easily a fluid flows under gravity and also under internal forces. That means it is irrespective of considering these external forces. So if you find out if it is given the kinematic viscosity, you can easily find out this dynamic viscosity. You just have to multiply this kinematic viscosity into density. You will get this dynamic viscosity, right? Question can become like that way also. So you are giving this value of kinematic viscosity and density. You are asked to find dynamic viscosity. So option D is the correct answer. So coming to this next question. So in this question it is given, for an incompressible fluid, does density varies with temperature and pressure? So that is the question, and four options are given. So please let me know which option you feel is correct. Even for this incompressible fluid, I have explained it a little ago, so I think that most of you can be able to answer it. So I am giving you 1 minute time. Please try to answer. Anyone? Anyone? Someone is saying option D. Option B. Okay. Good. It's feel good that you are trying at least. Hmm. Yes, yes, many of you are. Yes, and this is also answer Sharoj. Hmm. Yes. Harini said that incompressible means it's an ideal fluid, then it is practically not possible. I think yes, you are correct. In real life, there is no such ideal fluid concept, but for our calculation purpose, we are considering as ideal fluid. So it's like an assumption, because in real fluid there is variation in each and every term. Even whatever we are calling a fluid as incompressible, so in real life it can't be incompressible. There is some variation in densities also there. But that variation is negligible. Like you have studied about this about this approach temperature, or in limit you have studied x tend to 0, right? So this x tends to 0 means we are considering the value of x is 0, not exactly it is 0. It is near about, like the value of x is 0.001, exactly like that. So that effect we are ignoring. So everyone has answered it correctly. So that means the density always remain constant irrespective of the conditions. So so option B is the correct answer. So in theory, it's only always remember that whatever we are saying, it is on theory, not in reality. In theory, thus incompressible fluid are those in which the density remain constant regardless of pressure, temperature, force, anything. But in reality, no fluid is truly incompressible. Like water at low pressure. So we consider this as assumed to be incompressible for our simplification purpose. Even always remember this assumption, as I have discussed earlier, this assumption is quite essential if we are going to calculate suppose flow through a pipe. Okay, so you know the velocity, say you know the velocity and area of this region, and you have to, and also area of this region, you know this is A2, this is A1, this is V1. If you have to find this volume, then you have to apply this continuity equation. So for applying this continuity equation, it will be quite useful if we consider this ideal situation. Okay, so option B is the correct answer. Let us move to the next question. So in this question, it is given as given the compressibility of a fluid is given as 5 into 10 to the power minus 11 Pascal inverse. Then what is the bulk modulus of the fluid? And you should have to answer it in terms of gigapascal. So I am giving you 2 minute times. Just try by your own. So before this, let me clarify one thing. What exactly is compressibility? Compressibility is a measure of how easily a fluid volume decreases under pressure. That means you are applying a pressure, and what is the change in the fluid volume? That thing can be represented by this compressibility. So now try. So many of your answer test 20 option A. Okay, let's see what all other. Many of you have answered. Only other, please try. So let us solve this question. I think that many of you haven't studied about this concept of compressibility and bulk modulus. Okay, we are solving. So as I have said that compressibility measures how easily a fluid volume increases or generally decreases with pressure. So if I represent this compressibility as beta, say this compressibility as beta and bulk modulus at say k, some people are representing as kappa also, so I represent it as k, say. So basically the thing is that compressibility is inverse to that of bulk modulus. So bulk modulus represent what does this bulk modulus is? This bulk modulus represent the resistance of a fluid to compress. So as I said, that compressibility is the measure of how easily a fluid volume changes under pressure. And what bulk modulus did? It represents the resistance. Say if you are trying to change the volume of something, it will have some internal resistance. So right, if a solid is there, say a solid is there, and you are trying to put some pressure, so it will there is some internal energy which resists this decrease in the volume or changes in the volume. So something internal is there, so a constant is there that represents how rigid or how this body resists the compression. Since we are dealing with the fluid, so we have to represent it in terms of fluid. So basically this bulk modulus represents the resistance of a fluid to compression. Okay, so that means beta equal to 1 by k. So k equal to 1 by beta. So that means 1 by, what is the value of beta? That is 5 into 10 to the power minus 11. So that means 1 by 5 into 10 to the power 11. So it will move to the numerator. So I can write 10 to the power 11 as 100 into 10 to the power 9. So that is 20. So we got it as 20 into 10 to the power 9. So it is given that we have to answer it in terms of gigapascal. So basically 1 gigapascal equal to 10 to the power 9 Pascal. So that's why the answer is 20 gigapascal. So the correct answer is option A. So I think those who are not able to answer this question, now you got the concept. Is it clear to everyone? If anyone has some concern, please ask. You can also use your mic. Is this concept clear to everyone? Up to this 5 question. Okay. I hope that all of you have understand this concept. So I am moving to the next question. So next is also another numerical question. So it is based on the surface tension. So what is given if the surface tension of a water-air interface is 0.05 Newton per meter, the gauge pressure inside a raindrop of 0.5 millimeter diameter will be what? Okay, so I think this concept of surface tension has been discussed in the class. So and you have, I think, use this force balance, you can easily answer this question. So the first 5 questions are quite easy. Now the next 5 question is a little bit, its level is little bit higher compared to the first 5 one. So please try to answer. See here, this gauge pressure inside a raindrop. That means a liquid, say a liquid droplet is there. It always experience some internal pressure due to this surface tension. So the concept is same. Please try to answer. Say this question surface tension, you have studied about the surface tension. So one question anyone can ask you, why a raindrop or why a liquid drop is spherical in shape and not cylindrical in shape or any other shape? It's spherical in shape. Can anyone tell the reason? If anyone knows this reason, please open your mic and tell. So the question is, why a liquid drop is spherical in shape? So basically in a liquid, so this is based on this phenomena of surface tension. So this surface tension, say whatever the shape of the droplet, we know, say for a given volume, say if I fix the volume equal to 20, say. So for the volume, which surface, if I have a sphere, I have a cylinder, I have a cone, and any other shape you can take, a cuboid. If you calculate by yourself, you will find out that the total surface area is less. If this is the surface area, whatever with the surface area of the sphere, it is less compared to all the three other geometry. As the surface area is less for a given volume for a sphere, so basically because of the surface tension force, its tendency is to form a spherical bubble, spherical drop. That is to minimize this surface energy. So always everything has a tendency to minimize its surface energy. That's why always remember this droplet is spherical in shape. So now, yes, Shruta has answered this correctly. Good. Hmm. And please try now. Please try to solve this question 6 already. Two students have answered. Hmm. So let us start with this solution. So as I said that a liquid droplet, what is a liquid droplet? A liquid droplet generally experience internal pressure due to surface tension. So if this is a droplet, I have cut it through the middle cross section. So that will look like a hemisphere, right? So what will happen? The pressure force is gauge pressure is always acting inward, and if the same thing I and what is surface tension force? We know that the surface tension force always act on the surface. That means here it is the circular surface. So this surface tension force will act like that. So let us consider the surface tension as sigma and this gauge pressure inside as del P. Okay. Okay. So since these two pressure have to balance each other, else the droplet will not be able to maintain its shape. So we can write pressure force equal to surface tension force. So pressure force, what is the pressure? Here the pressure is del P, and since it's force, so we have to multiply this area, cross section area. What is the cross section area of the circle is pi by 4 d square, right? And surface tension force act on the periphery, that is on the circumference. So that is sigma into what is the circumference of a circle, that is pi into d. Now you find out, you will get 1d will cancel out, so you will get d equal to 4 sigma by del p. Okay, so you have to find out the pressure. So del p equal to 4 sigma by d. So sigma is given this one and diameter is given 0.5 mm. So see, I have said that if something, you have to compare the unit in the same term. So it is in meter and it is in millimeter. So it should have to convert into meter. Then it should be 0.5 into 10 to the power minus 3 meter. Now put this value, you will get the answer. That is 4 into 0.065 by 0.5 into 10 to the power minus 3. So minus 3 will rise upward and just calculate using a calculator. So you will be getting 520 as the answer. So basically in a droplet, what is balancing each other? The pressure force is balancing the surface tension force. So that concept is used even in printing. You have seen an ink are used. So in this ink also this concept is used. That is the pressure tension force and the surface tension force are equal to each other. And even in a emerging field which you know, that is microfluidic, if someone is interested in research in microfluidic, they will, this concept is quite vital for them also. So option uh, C is the correct one. So I am moving to the next question. So here this is a surface tension is due to H. So you have to fill this blank. So these options are adhesion, viscous force, difference between adhesive and cohesive force, and cohesion. So these are the four options. So please try to answer. So please try to answer. Kritika say D, that is cohesion. Other? So please try. Risha says C, the difference between adhesive and cohesive force. And MC said D, cohesion. So there is a confusion between option C and D, right? So let us see. So to understand this, first know about this adhesion and cohesion force. What is adhesion and cohesion force? Say this is the liquid level. Okay. So surface tension, what basically is a surface tension? This surface tension basically is the force acting on the surface of the liquid. This surface of the liquid. Why? What type of force? This is because of this molecular interaction. So this is water. Say this is water molecule in microscopic level. So whatever may be the interaction of this force, so one water particle is attached to another one, so it is trying to attract each other. So that's why because of this we are getting this surface tension force and interaction between these two same particles. This is water molecule between two water molecule or any other molecule of same particle, same material is known as cohesion. cohesive force. And if it's between the wall and the liquid, say this wall in microscopic level, wall is made up of some material, and even liquid has some molecules. So this molecule of the wall and this molecule of the liquid, if there is interaction between these two, then it is known as adhesion. So that means it should be two different ones. So basically because of this cohesive force we are getting this surface tension, and this adhesive force, whatever I am talking about, this adhesive force, you will studied about this capillary rise or fall. This is basically mainly because of this adhesive nature. So this surface tension force is mainly due to cohesion and not because of adhesion or adhesive force. Okay. So even if you consider if someone have some confusion, then let us assume a spherical bubble, spherical liquid droplet. So in this spherical droplet there is no such wall. So there is surface tension force also. So how this surface tension force come here? This is mainly because of the interaction between the same molecules of the same particle, that is water. So surface tension force is mainly because of cohesion. So option D is the correct answer. So is it clear to everyone? Okay. So let us move. Huh. Yes. Huh. Okay. Okay. Sure. Say what I am saying here is that, say a water droplet is there. This is a water droplet. Okay, it will always try to maintain its shape, as I have discussed in the earlier one. This is because of surface tension force and the pressure force, inside pressure force balancing each other. But forget about this pressure force. If I only talk about this surface tension force, so surface tension force basically is the interaction between these molecules. Say a solid is there, consider a solid is there. So we know in a solid these particles are closely packed with each other, right? Whereas in a liquid, what will happen if it's a solid? Whereas in liquid, the liquid is not that much of closely packed, and if it's an air, the particles are, these molecules are quite far away from each other. So that is the basic concept in a solid, liquid, and vapor. So see, that's why if in case of solid, in case of this liquid, say this is the sphere. In this sphere, at the curvature, that means at the periphery, there are a lot of molecules, liquid molecules, right? So what this molecule did, say this is the two corresponding molecules. One molecule try to bind with another molecule. Okay. Similarly, the next molecule try to bind with another molecule, and because of this binding, this spherical nature remains the same. So this explanation is on the microscopic level. So as similar, this is water molecule, this is water molecule, these two are same molecules. So the interaction between same two molecules is known as cohesive. And if say this is a surface, so if the water droplet is here, so what will happen? This is an water molecules, right? And this black one is the wall molecule. So this one is the water wall molecule, and this one is the liquid molecule. So there is an interaction between these two one. So these two interaction, that means they will try to bind each other. These two molecule is known as adhesive. Adhesive force. This force is known as adhesive force. This force doesn't play a role in the surface tension, but it plays a role in the adhesion, or you can say in the capillary rise. Say in a test tube, if you are putting some water, you will find that the liquid level is like that. An U shape you can observe, or you can observe reverse U shape. So this U shape is mainly because of this adhesive. But in surface tension, this adhesive force doesn't play a role. Is it clear to you? Hello? Okay. So I'm moving to the next one. So now the question is viscosity of a liquid blank with increasing temperature. So you have to fill this blank. So these are the four options. So this concept is also correlated with the previous question. So try to answer. Hmm. Okay, many of you are yeah, great. Hmm. Yes. Okay. So everyone of you have answered it correctly. So see, those who haven't understand this concept, so let us understand this thing. So what basically is viscosity? So viscosity is the resistance to flow due to internal molecular interaction or friction. Okay. So as I have said, water molecules are there inside the liquid. So this molecule will the motion of this molecule is important. So this viscosity, what this viscosity did, it resists this flow of this molecule. So here the question is with increasing temperature. Say if we are applying heat to this vessel, we are applying it. That means temperature, we are providing temperature to this thing. So we know if the we are providing temperature to any liquid, its molecule gain some kinetic energy, right? That means heat energy is converted into kinetic energy. We are giving heat energy and the molecule will get some kinetic energy. So each molecule has some kinetic energy, say kinetic energy, it has some kinetic energy. So because of this kinetic energy, this molecule will try to move away from its near about molecules. That means it will separate each other. So if separation is there, that means this intermolecular interaction, whatever may be the molecular interaction, that is the cohesive force between two particles will reduce, right? Force, or we can say inter intermolecular force. So this intermolecular force reduce. Why it will reduce? Because the molecule will gain some kinetic energy because of the heat, and it will try to move away from each other, and that's why this intermolecular force reduce. Okay, so that's why its resistance to flow will also reduce. So the viscosity of the, that means the viscosity will also decrease or reduce. As because viscosity is the resistance, that means the tendency of the viscosity is to resist the flow. It cannot be easily allow the liquid to move. But as because of the temperature, the kinetic energy is increasing, intermolecular force reduced, so the particle will be easily able to move. That means viscosity is less. So option D is the correct answer. So is it clear? Now I am moving to the next one. So this is another question. This is a basic question, and it will hardly take 30 seconds to answer. The SI and CGS unit of dynamic viscosity of a fluid is given as Pascal second, hmm, Pascal second and poise respectively, and that means SI unit and CGS unit both are given. So what is the relation between these two? So you have to answer. Please try to answer. Hmm. So only one student has answered. Other, please try to answer. Let us see how many of you have answered it correctly. So okay. So given as a unit and CGS unit, right? As a unit is Pascal per second, and it is Poise. So Pascal means Newton. So that thing is not necessary what I am writing, but question may come like in the previous one, convert this Poise into Pascal per second or Newton per meter square second. So that type of question can also be asked. So that's why I am elaborating this thing. Since it's a CGS unit, it should be gram centimeter per second, or we can write dyne by meters centimeter square per second. Okay, so that is the thing. So basically, what we know? We know that. Can anyone tell what is the formula? What is the conversion? Not the formula. I think no. See, see, it is 1 Pascal per second equal to 10 poise. This is the conversion. So that means 1 poise equal to 1 by 10. So we can write 1 poise equal to 1 by 10 Pascal per second. Okay, that means 10 to the power minus 1. Option D is the correct answer. So I am moving to the next one. So it is given a fluid in which the shear stress is more than the EL value and is proportional to the rate of shear strain is known as what? So it's a good question. You have studied, if you have studied about this Newtonian and non-Newtonian fluid, then you will be easily able to understand this question or able to answer this question. So that is the question. Please try to answer. Anyone? So no one knows the answer. Can I assume? At least try. Hmm. Punjab say option E. So I think no one knows this answer. Okay, let us see. The options are these: Newtonian, ideal fluid, real fluid, and plastic. These are the, yes. So now it's a the concept for this non-Newtonian fluid. Say for this non-Newtonian fluid. So basically this shear stress, we have formula A plus B so also you have studied a formula tau equal to dou u by dou y, mu into dou u by dou y. So all this formula of any fluid can be represented in this term, tau equal to A plus B, this term. Okay. So for Newtonian fluid we know tau equal to mu into dou u by dou y, right? So in case of Newtonian fluid, it is tau equal to A should be 0. That means if I represent, okay, B dou y, that is for a Newtonian fluid. That means A should be 0 and mu should be 1. So that is for a Newtonian fluid. So option A will not be the answer, right? Okay. So another thing is that next in real fluid. So in real fluid basically, so in the question the given the fluid in which the shear stress is more than the EL value. So EL value means this value. So if it is more than A, tau should be more than this value. So there should be certain value. So in ideal case this cannot be the scenario. This formula doesn't directly apply. So in case of ideal plastic fluid, what happens? A not equal to 0 and n equal to 1. Okay, because see why I am saying this thing, because in the question it is given the shear stress is more than the EL value. That means A cannot be 0. Already it is given a EL value is there, so it should not be 0, and is proportional, and it is saying that proportional. Proportional means there shouldn't be any power. So that is the condition given in the question, and this condition is only satisfied for ideal plastic fluid. Okay, so the correct option is option D. Is it clear to everyone? So if I talk about an example of this ideal plastic fluid, in our real life we are using toothpaste, so that is an example. Okay, so in toothpaste you just see, if you press this, so a small volume can only eject out of this paste tube if this shear force is more than whatever be the required EL value. So in that scenario also, in butter also same phenomena is there. So the correct option is option D. And this formula, the formula that I have taken, this formula is used for all the non-Newtonian field. But in non-Newtonian field, you can't say about this value of n without giving if someone doesn't tell about these things, what is the value of this N or B or A, you can't be able to say whether it's a which types of non-Newtonian fluid. That's why the choice that fits here is the ideal plastic fluid. So I am moving to the next one. Sorry, there is a, okay, because of mistake these things are coming here. Just try to solve this one. In this, here it is given the capillary rise of water in a 1 mm diameter tube is 3 centimeter. The height of the capillary rise of water in a 0.2 mm diameter tube in mm will be what? So that is the thing, or that is the question asked. So please try to answer by your own. So as already a few questions back I have discussed about this capillary rise or capillary fall concept. So here also similar to that this will be used. So please try to solve. Okay, anyone? Division, see anyone? Monroe? Ravi said A. Ravi just Vidisha said A. So one thing I will suggest you here, everyone please see this unit. Some units are in millimeter, some are in centimeter. So please consider this point while solving. So two students have answered option A. Okay. So now let us solve this one. Okay. I am solving this one. Say this is the capillary rise problem. Say this is a tube, right? So this is the capillary rise action. here there is liquid, this is liquid, all these things represent this liquid. So what basically is happening here is that in the capillarization, say this is the surface tension force. The surface tension force will act like this way, and this surface tension force should be balanced with this weight. So weight of the fluid, that means this weight, I am talking about this weight. Okay. Hmm. So what should be the thing is that weight of the fluid equal to surface tension force. So they should balance each other. Say in this portion I am drawing. So this is the basically this portion looks like this way. So this means the weight means mg. I can write it as mg, and the surface tension force can be write as c. Surface tension, say it is sigma. Surface tension force, surface tension can be written as sigma. So it will act at an angle, right? Okay. To say it makes an angle theta. So if it is sigma, then it should be sigma cos theta. So I can write sigma cos theta is the surface tension into its circumference. So this force will act throughout this periphery of the test tube. That means the circumference of the test tube, which is pi d, right? Again, the mass of the fluid, we know mass equal to density into volume. That means rho into how much density? Say density into volume, sorry, area into height, right? This height. So this one equal into h into g equal to cos theta into pi d, right? So you see there pi and d will cancel out. So what you will get, h equal to just solve, you will get this thing 4 cos theta by rho g d. So see whether you are getting this thing or not. This is for the capillary action. Whether you are getting this thing or not, please let me know. Robbie has rectified his answer. Windows also answer. Whether this concept is clear to everyone, first let me know this thing. Yes or no? I think this. I think you have understood this concept. Okay. I am assuming that you have answered this concept. So what I have got, I have got h equal to 4 sigma cos theta by rho g d. See, in this question, uh, what is given? The capillary rise of water in a 1 tube, 1 mm diameter tube is 3 mm, the height of the capillary rise of water, see, it's a water. That means the property, this property, density, surface tension force, and theta, all these things will not change because it's water. If any other fluid is there, then it may change. So, and gravity is always constant. So, I can say that H is inversely proportional to 1 by D, right? So, I can write this thing. So, H2 by H1 equal to D1 by D2. So, you understand how this thing has come. So, we have to find out H2. That means H2. This one is D2. This one is diameter is given. That means this one is D1 and this one is H1. So all these value are given here. So if you put it here, you will get the answer. 30 by 0.2, that means 300 by 2, which is 150. So our correct answer is 150. So why it is 30 you got it? Because it is in centimeters. So we have to convert it into mm. Okay. So this question is quite important. Such types of question, if someone is appearing for this NPTEL course exam, you may expect such types of question on this capillary rise program. So, and I always suggest you, either you remember this formula, it is quite tough for some students, so better you go through this concept, which is weight of the fluid is equal to the surface tension force. If you know the concept, you will be easily able to derive this formula and you can easily able to answer this question, and it will hardly take 1 minute to derive. So you should be fundamentally strong in this concept of this capillary rise and capillary fall program. So I am moving to the next one. See, this is in, so it is matching this group 1 with this group 2. So its unit, some units are given and some specific nomenclatures are given. You have to check which one will be the answer. So I will give you 3 minutes to answer this. So I am waiting 3 minutes. So please try to answer. So here 5 options are there. Hello, 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 Robi. Are you saying anything? Hello, hello, Ravi. NCR answered option E. Let's see other. Vidisha is also go with option C. Option E. Gary has also answered E. Okay. So yes, the correct option is option E. So see how this is answered. Yes. So this is the, you see, if you see here, all these are in SI unit, right? So the first is the dynamic viscosity. So dynamic viscosity, I have already derived this thing earlier. This is Pascal second. Okay. So already option A is for 5. So see, only we are getting option A and E. So rest 3 are not the answer. So now specific OH. What is specific OH? You know specific OH equal to OH by volume. So OH means it should be Newton and volume means meter cube. That means Newton per meter cube. Here one option is that kilonewton. This is in kilo. Kilonewton, yeah, it can be in kilo, not an issue. So option B, this one is for option B, right? B is 4. See, in both option B is 4. So next is energy. The energy, we know energy equal to, what is energy? Energy is force into distance. So force is Newton, distance is meter. So Newton meter is option. This is for C. So already this option has been cut out because it is shown 2 and here it is 3. So option A is correct. Still, we will go for this specific volume. Specific volume means, you know, specific volume is 1 by density, or I can say specific volume means, that means I can write as volume by mass. So volume is meter cube by kg. So that is equivalent to option 2. And rest is surface tension force. So it's a force, so it should be in Newton. So option A is the correct option. Okay. So I am now moving to the next question. So it is given the equivalent head of the mercury corresponds to 6 kilopascal is, you have to find out this thing, and given the specific gravity of mercury as 13.6. So specific gravity is given. So please try to solve. So please try to answer. See, I think many of you know this concept of equivalent head. So before answering this, I am explaining about this equivalent head. So equivalent head or pressure head, what this thing is. So pressure head. Pressure head means the height of a fluid column corresponds to a given pressure. Say this is a tube. So this is the volume up to which the tube is filled. Okay. So there is a certain pressure at this point 1, and at point 2 pressure is different, point 3 pressure is different. So if we have to represent this pressure, generally pressure is in Pascal. So if we have we will try to represent in term of height. So at point 3 corresponds to this pressure, the height is h3, corresponds to this 2, the height is h2, and corresponds to 1, the height is h1. That height is known as equivalent height or pressure head. Okay. So also you have studied the formula rho equal to, okay, sorry. So I am erasing all these things. Now let's leave this thing. We know that P equal to rho G H. So see, in the pressure always we represent it in terms of height, right? So that is the concept here. So now I hope that you will be able to answer this thing. So please try. Also the specific gravity is given. Okay, I am giving you another hint. What is specific gravity? Specific gravity, say I represent specific gravity, this specific gravity equal to density of the liquid. That means the liquid which is required by density of water. Okay, so that is the specific gravity. Specific gravity means density of a liquid, given liquid by density of water. That means the reference is water, and we know the density of water is 1000, right? So accordingly you can find out this density of mercury. So I think, see, and one thing is that specific gravity in general, specific gravity is a non-dimensional term. Not non-dimensional, it's a non-dimensional term. Yes. So you can try to solve. Anyone? Anyone? Okay, you want me to solve this one, or you will try for a few more minutes? Okay. Delicious is option C. Yes, it's right. Good Vidisha, it's right. So the thing is that, so already I have said this thing here. So specific gravity for mercury is already given as 13.6. So that means density of mercury by what is the density of water? It should be 1000. Okay. So already the pressure, what is the pressure given? The pressure is 6 kilo Pascal. Now that means 6000 Pascal. So I can put here 6000. Density, this is for mercury. You have to find out for mercury. That means here density is 13.6. Okay. 13.6 into 1000 into, say, so let us take the value of G as 10 and H, or you can take 9.8. Accordingly, you just try to solve this one. So 3 will cut out. So accordingly, it's 136 by 6. So you will get answer. You just calculate and check whether it is correct or not. So on solving, you will get option C as the correct answer. So is it clear to everyone? So you understand the term, this is equivalent head of mercury means the height equivalent to a specific pressure head. So that is our answer. I hope that you understand this thing. So last two questions are there. So now please try to solve this one. Here it is given a plate 1 mm distance from a fixed plate moves at 2 meter per second and require a shear stress of 2 Newton per meter square to maintain this velocity. Find the viscosity of the fluid between these plates. So what is given? A distance is given, a velocity is given, and a shear stress is given. You know, you have studied this term shear stress, right? So there is nothing they have mentioned about this fluid. So we have, if nothing is mentioned about this fluid, we have to assume this fluid as Newtonian fluid. If nothing is given, always consider the fluid as Newtonian fluid. Now already the shear stress is given. We know the formula of shear stress, right? Tau. So you know this formula as I have explained in a few question back. So I think that now you can be able to solve using this concept. In Newtonian fluid, you know this formula, tau equal to mu into u by y. So use this formula and solve du by dy. So everyone please try. So the formula from the Newton law of viscosity, we have tau equal to mu. This is the change, or we can better write this is change in, what does this represent? Change in velocity, and this is change in the distance. Okay, so now you can put. Okay, I'm giving 1 more minute to solve. Just try to solve. That says answer option B. Yes. So we solving. Yes, Vidisha, is answer is correct. Good. So that is the formula here. So that what I have said, that W means the change in velocity. So I can write it as U final minus U initial. Similarly, I can write it as Y final minus Y initial. So what is given here? So this tau is been given as 2, and you have to find out the viscosity. So the plate moves at this velocity. So final velocity is given, initial is not given, so we consider it as 0. So similarly, given that the plate 1 mm distance from a fixed plate, so that means it is moving 1 meter. So that means 1 minus 0, right? And another thing is that it is in millimeters. So we have to convert it into meter. That means minus 10 to the power 3. Okay. So that means 2 and this 2 will cancel out, or we'll get mu equal to 10 to the power minus 3. So option D is the correct answer. Okay. So this is the correct answer. So we are moving to the last question of this session. So in the last question, it is given that an oil of kinematic viscosity is given, and also the specific gravity is given. Then what is the dynamic viscosity? So I think it's a simple question for all of you. Since as already you got this concept, specific gravity is given. From specific gravity you can find out density, right? Also dynamic viscosity is given. So from this kinematic viscosity is given. So you can use this formula to find out this dynamic viscosity, because we know dynamic viscosity equal to So you have to find only the density. So please solve. So those who are present, please try to solve. B. Vidisha is answered. Yes, this is right answer. So the specific gravity is given. So we know if they say specific gravity, this one represented this one. So specific gravity is the density of what? Say density of any fluid F by density of water. So that means here this density of this fluid equal to, already this value is given as 0.60 into 1000. So that means it's 600, and already this value is given. Sorry, we have to find out this dynamic viscosity, and given kinematic viscosity is given. Kinematic viscosity means this one is value 1.5 into 10 to the power minus 4. So this one is mu is given. So we have to find out mu. So that is 600 mu. So if you multiply this, you will get mu equal to a value 1.5 into 60, that is 9. So you will get 0.09 as the answer. So that is option B. So this is the last question. So we have completed this question summary for today. So any question, so you can just on your mic and ask. And any types of problem or anything you are facing. Also, if you after this session or while studying these courses, if you find any question, you can mail me at this mail ID. Mhm. So you can also put a mail about your problem. So I am also providing my mail here. So so you can use this mail ID to contact me. So today most of you have answered, and Vidisha have also answered most of the question. So I appreciate for this effort. So anyone having any question or doubt, please. So if you don't have any question or yeah, so we are closing this session. Okay. So thank you everyone for joining this session and hope that you will enjoy this session. And you, if you have any doubt, you can contact me anytime. So we'll meet on this next week on the same time. Thank you and have a good day.